Hello students, we were discussing chapter 1 rational number of class 8. In earlier video, we discussed closure property of rational number. We discussed for integers, we discussed it for whole numbers and rational numbers. Now second property is closure, after that commutative property. Second property is commutative property. What is commutative property? We will discuss this commutative property for integers, whole numbers, and then at last for rational numbers. Then we will proceed for next property. Let us see what is commutative property. Commutative property. If I will add two numbers in A plus B order, and then if I will change their order, A plus B must be equals to B plus A. This is commutative property under addition. Okay, we want to discuss in deep. Let us see for integers. Integers. Operations, under four operations we will discuss. Operations, and then examples, and after that what is conclusion? What is conclusion? Let us see. Operation is addition. Operation is addition. We are discussing it for integers, so we need to take two numbers. Let A and B belongs to integers. A and B belongs to integers. Then if A plus B is equals to B plus A, then we can say addition is commutative in case of integer. If A plus B is equals to B plus A, then addition is commutative in case of integers. Let us consider examples. A and B. Let A is 2 and B is minus 5. A is 2, B is minus 5. Then 2 plus minus 5 must be equals to minus 5 plus 2. Simplify, it is 2 minus 5 and it should be minus 5 plus 2. Answer is minus 3. And there minus 3. Both sides are equal. Means A plus B is equals to B plus A. Many more examples we can discuss. We can say if A plus B and B plus A are equal, we got A plus B is equals to B plus A, then this addition is commutative. Addition is commutative. In conclusion, we will write addition is commutative. Commutative. Addition is commutative. Okay. See next, in case of subtraction, we want to check whether subtraction is commutative or no. Subtraction. Let A and B belongs to integers. Then if A minus B is equals to B minus A minus B is equals to B minus A, then I will say subtraction is commutative, otherwise no. Let us see. Put value of A and B. Let A equals to 2, B equals to minus 3. Then it is 2 minus minus 3 must be equals to minus 3 minus 2. It will be 2 minus minus plus 3. Answer is 5. And this side it is minus 6. We can say minus 5 is not equals to minus 6. 5 is not equals to minus 6. So we got A minus B is not equals to B minus A. It means subtraction is not commutative. Subtraction is not commutative. Subtraction is not commutative. We checked addition is commutative and subtraction is not commutative in case of integer. Now under operation multiplication we want to discuss. Under operation, multiplication. Multiplication. See, if A into B is equals to B into A, then we can say multiplication is commutative. If A into B equals to B into A, then subtraction multiplication is commutative. Consider example from integers. Let A equals to 0 and B equals to minus 15. Then A into B, 0 into minus 15 must be equals to minus 15 into 0. 0 into something 0, and same here. We got A into B equals to B into A. It's mean what it indicate? It indicates that multiplication is commutative. Multiplication is commutative. Multiplication is commutative. Okay. Next operation is division. Next operation is division. Okay. If A divided by B is equals to B divided by A, what it will be under under operation division? A divided B must be equals to B divided by A. If this condition is satisfied, then we can say division is commutative, otherwise no. Let us see. Put value of A is minus 2 and B equals to 3. Then divide minus 2 divided by 3. Answer is minus 2 by 3. And B divided A, it will be 3 divided by minus 2. Answer is 3 by minus 2. We can say minus 2 by 3 is not equals to minus 3 by 2. Its mean division is not commutative. What it meaning? Division is not commutative. Let us write our conclusion. Division is not commutative. Division is not commutative. You can check it by another example also. More examples you can try here. Okay. Let us discuss this commutative property for whole numbers. Let us discuss this commutative property for whole number. Okay, we know what are whole numbers. The real number which starts from 0 and goes up to infinity. Whole numbers. This commutative property for whole numbers, under 4 operations we are going to discuss. First operation is addition. What is first operation? Addition. Okay. Consider their examples and property, and then conclusion we will write. Let this A and B, this time this A and B must belongs to whole number. If this A plus B is equals to B plus A, then we can say addition is commutative. Then addition is commutative, otherwise no. Let A equals to 0 and B equals to 5. Let us check. 0 plus 5 must be equals to 5 plus 0. It is 5 and this also 5. So we can say addition is commutative. Addition is commutative in case of whole number. In case of whole number. What it meaning? You are taking two numbers, suppose 2 and 3. Add these in any order. Either add 2 plus 3 or add 3 plus 2. It's mean you will get the same answer every time. So it's mean addition is commutative in case of whole number. Addition was commutative in case of integer, and now addition is commutative in case of whole number also. Next operation is subtraction. Next operation is subtraction. Now, if this A minus B is equals to B minus A, then I will say subtraction is Subtraction is commutative, otherwise no. Let us see, verify it with the example. A value, let A equals to any value 5 and B equals to 6. A minus B, that is 5 minus 6. It must be equals to, if it was commutativity property, B minus A, 6 minus 5. Its answer is minus 1, which is not equals to 1. Minus 1 is not equals to 1. It's mean what we can say, subtraction is not commutative. Subtraction is not commutative. Subtraction is not commutative in case of whole number. Subtraction is not commutative. Let us discuss under operation multiplication and division. Under operation multiplication and division. At last for division. Examples we need to write there. Examples. Okay. If this A into B is equals to B into A, then I will say multiplication is commutative, otherwise no. This time we need to consider this value of A and B from whole numbers. Let A equals to 2 and B equals to 0. Okay, let us discuss. A is 2 and B is 0, and there 0 into 2. Answer is 0 is equals to 0. Yes, what we can say, multiplication is commutative. Multiplication is commutative. Multiplication is commutative. Okay, see, what is conclusion? If you are taking any two integers, any two whole numbers, two rational numbers, for rational number we will discuss next, then multiply them in any order. Multiply them in any order, A into B or B into A. Doesn't matter, your answer will be same. It's mean multiplication is commutative in case of whole number. Okay, next, under operation division we want to check. If A divided by B is equals to B divided by A, then we can say division is commutative, otherwise no. Let us see. Let A equals to 3, B equals to 17. A equals to 3, B equals to 17. Let us divide A by B. Find out A divided by B. This is 3 by 17 and B divided by A. It is 17 by 3. 17 by 3. Clearly, A divided by B is not equals to B divided by A. A divided by B is not equals to B divided by A. So we can say division is not commutative. Division is not commutative. So in short, if I will tell to you, then addition is commutative, subtraction is not commutative, multiplication is commutative, and division is not commutative. See, in short, we can say Addition is commutative, subtraction is not commutative, multiplication is commutative, and division is not commutative. It is same in case of whole number and integers. Okay. Now finally, this commutativity property we are going to discuss under in for operation and in case of rational number. Commutative property for rational number. This commutativity property for rational number. Now, for rational number, under four operations we will discuss. Same addition, subtraction, and multiplication. Let us see first addition. Addition. Their examples and then their conclusion we will see. Okay. Addition. This time we need to consider these A and B from rational numbers. A and B must belongs to rational numbers, and if A plus B is equals to B by B plus A, then we can say addition is, what we can say? We can say addition is commutative, otherwise no. Let us verify. Let A equals to 2 by 3 and B equals to 3 by 5. Okay, A plus B, that is 2 by 3 plus 3 by 5 must be equals to 3 by 5 plus 2 by 3. Take LCM, it is 15. 3 5s are 15, 5 2s are 10, 5 3s are 3 3s are 9. It is, what is LCM? 15. It will be 5 3s are 3 3s are 9 plus 3 5s are 5 2s are 10. 10 plus 9, 19 by 15, and there also 19 by 15. What we conclude, what we observed there? We observed A plus B is equals to B plus A. A plus B is equals to B plus A in case of rational number. So we can say addition is commutative in case of rational number. Or we can say rational numbers hold commutative property under operation addition. Now for subtraction we want to check. Next property, next operation, subtraction. Subtraction. Let us see. Consider this A and B from rational numbers. If A minus B equals to B minus A, then we can say rational numbers hold commutative property. Rational numbers hold commutative property under operation subtraction. Let us see. Let A equals to 2 by 3 and B equals to 5 by 6. Okay, A minus B. Calculate A minus B. 2 minus 3. 2 by 3 minus 5 by 6. Okay, what will be LCM? 6. It will be 4 minus 5. Answer is 1 by 6. And then B minus A. What is value of B? 5 by 6 minus A 2 by 3. Again LCM is 6. 5 minus 4. Answer is 1 by 6. What we observed? We observed A minus B 2 by 3 minus 5 by 6. there it is minus 1 by 6. Okay, we observed a minus b is not equals to b minus a. A minus b is not equals to b minus a, because the 4 minus 5 minus 1 by 6, and there 5 minus 4 1 by 6. A minus b is not equals to b minus a. Its mean subtraction is not commutative. Subtraction is not commutative. Its mean rational numbers doesn't hold a commutative property under operation subtraction. Rational numbers doesn't hold commutative property under operation subtraction, but rational numbers hold commutativity property under operation addition. Now let us check it under operation multiplication. Okay, now this time if a into b equals to b into a, then we can say rational numbers hold commutativity property under operation multiplication. Let a equals to 2 by 3 and b equals to 5 by 9. Multiply a into b. What is a into b? 2 by 3 into 5 by 9. Answer is 10 by 27. Then b into a. What is b? 5 by 9 and a value is 2 by 3. Answer is 10 by 27. It's mean multiply two rational numbers in any order. You will get answer same. Multiply either a into b or b into a. In all case you will get the same answer. Okay, what is our conclusion then? Multiplication is commutative. Multiplication is commutative. Okay, in other wording what we can say, rational numbers hold commutativity property under operation multiplication. Let us discuss with last one, operation division. Now if a divided by b is equals to b divided by a, then we can say division is commutative. Let us first of all discuss this property. At last we will write our result. Okay, let a equals to same 2 by 3, any different example you can consider, and b equals to this 5 by 9. Divide. Find out first a divided by b. It is 2 by 3 divided by 5 by 9. That is 2 by 3 into 9 by 5. 3 1 are 3, 3 3 are 9. Answer is 6 by 5. Now find out b divided by a. What is value of b? 5 by 9 divided by 2 by 3. See, this 5 by 9 as it is, then it will be 3 by 2. 3 3s are 9, 3 1s are 3. Answer is 5 by 6. Clearly, a divided by b is not equals to b divided by a. That is 6 by 5 is not equals to 5 by 6. So we can say a divided by b is not equals to b divided by a. Its mean division is not commutative. In short, what we can say about commutativity property in case of rational numbers. See, but in addition is commutative in case of rational number. If we will say rational number, subtraction is not commutative. Multiplication is commutative. Multiplication is commutative and division is not commutative. Okay, we discussed closure property. closure property, commutativity property, under four operation, addition, subtraction, division and multiplication. Now, and in case of integer, whole number and rational number. In next section, we will discuss next property, distributive property. In next section, we are going to discuss distributive property. Thank you.